Okay, in this video, we're going to be looking at using LangChain to chat with and query PDF files. And more importantly than that, I'm going to introduce a whole bunch of different elements that we're going to use in a lot of the things coming up on videos as well. This is the game plan. And this is the key thing to understand here is that while we can, while we could do a simple questionnaire over something and feed that into the context of the prompt, if our prompt is limited to 4,000 tokens or perhaps maybe even 8,000 tokens with a GPT-4, it's still a very finite thing. And if we wanted to go through a book, it's not going to work that well. So this is where we're going to introduce a whole bunch of new things that relate to vector stores, embeddings, using queries to queries and retrieval to get information that we're going to basically use for doing our chat with our PDF file. So the way this works is we're going to have a document, and the document that I've chosen is this. So this is a book by Reid Hoffman that he's released all about GPT-4 and all about AI. And he actually wrote it with GPT-4. Right. And I don't think he's put out the book to make money. He's basically put it that you can order it on Amazon or you can download the free PDF. And that's exactly what we've done here. I've basically just downloaded the free PDF, and you can see that it's got quite a number of pages. And we're going to go through and we're going to convert this PDF into something that we can query and that we can talk to as we go through this. So the first thing that we're going to be doing is we're going to be just loading in the PDF file, and we're going to split the document into chunks. And the idea here is that we're going to build a vector store. And the vector store, we're going to query that vector store. So just like you would with a search engine, we're going to be looking for things in that vector store. But rather than do it through keywords, we're going to be doing it through semantic meaning. And this is done, I'll look at doing a whole video about the concept of embeddings, but what we're going to do is we're going to make an embedding for each chunk in here. And that embedding is going to be a vector. It's going to be quite a large vector, because we're actually going to get, in this case, we're going to get OpenAI to basically make that vector for us. And that vector will be representative of all the information that's in that chunk. So if we ask a question about some information, when we basically embed the question, which we're going to do later on, we would have like our standalone question, we would embed that, and then that will go to the vector store. And the vector store will then return the chunks of information that are most relevant to what we want. And then they will be passed into the language model along with our question. And then the language model will basically decide, okay, reading through these, what is the answer? The idea of this sort of semantic search thing is not a new one. It's been around for a long time. And even the idea of using a large language model to query a section of text is also something that's been around for a long time. So there've been some famous data sets like Squad, and people would train up models like BERT on doing this kind of thing. And it turns out that this is something a model can do pretty well, that if you give it some text in its context, later on we'll look at the prompts to see how this is done, that it can then look through that text, work out, okay, what relates to the question asked, and then return an answer for this. So there are a number of key things we've got to do here. We've got to basically load up the document. We've got to split the document. We've got to create the embeddings. We've got to put it in a vector store. So a vector store is like a database. And then we're going to basically use LangChain to create our chain, which can then basically take a query, look up a vector store, get the information back, bring that into the chain, and then combine that to finally come up with an answer. Okay, so here you can see I've got the data for downloading this, and we've got our first things that we're going to be bringing in. First off, we've just got a PDF reader. Now, I'm not saying that this is the best PDF reader. In other videos, we'll look at using some other ones and stuff like that. The idea with this one is everything's simple, and then we'll do other videos about each specific part for this. The embeddings I'm using, they're OpenAI embeddings. You'll see in future videos that I will show you free ways that you don't need to pay for these embeddings and use OpenAI. We need a text splitter, and then we need a vector store. And in this vector store, I'm just going to store it in memory with a library called FAISS or FAISS here. Okay, first up, reading the PDF in. So we've got our PDF reader. It brings in the PDF, and you can see that from this, we've basically got a text, and we've got our text as one long string in here. And if we look at how many characters that is, we can see that it's almost 360,000 characters. If we look at just the first 100 characters, we can see that this is what we're getting out. Now, you can see that the formatting is not great, right? We've got some spaces in weird places and stuff like that. This is where over time you would try out different kinds of ways to bring your data in. And it will be different for each project. For some projects, something really basic will work well. For other projects, you'll want to use a library called unstructured. For some projects, maybe you want to use an API from AWS or Google Cloud, etc. Right, but we've brought that text in now. The next thing up is to basically split it up. So here we've got a text splitter, and this is the most basic kind of splitter here. We're literally just splitting on the number of characters. And so we're basically going to say that, okay, we're going to have a chunk size of 1,000 characters, and then we're going to stride over it. So what do we mean by that? We mean that there's going to be an overlap. So imagine if I've got a few sentences, and half the thing I'm talking about is in the first two sentences, and then I split, and then half of it was in the second two sentences. So maybe I've got like 50 sentences, but the last two sentences have got a key piece of information, and they go on to the first two sentences of the next chunk. So in that kind of case, to prevent that, we have this moving window, which is this chunk overlap, and we slide this across. So this is basically going to mean that we're going to have an overlap of 200 characters for each chunk size. So a lot of the text, or a portion of the text, will appear in more than one chunk. But because we're taking the whole semantic meaning of that we're going to make an embedding, it's going to be different from chunk to chunk. So each chunk will have its own semantic meaning in there. But just in case something was going to overlap, we want to make sure we can catch that. So there are a whole bunch of strategies for this, depending on what your data is. I'm using a very small overlap here. You do want to use some overlap. I see some people tend to use none. You really would like to use some overlap. But then for certain things, if the meaning is changing quite quickly, you might have an overlap of 500, so that you're taking like the first 1,000, moving 500 along, taking from 500 to 1,500, moving along from 1,000, right? Obviously, that's going to create a lot more chunks. So you have to balance the number of chunks you're getting with the amount of overlap that is going to be good for you. All right, so we've got that. You can see after that, we've ended up with 448 different sort of texts or little mini documents here. And if we look at some of these, we can see that, okay, if we look at the 20th one, we can see that it's obviously starting with half of a sentence from the previous one. It's going along as we do this. And we can see that, okay, it's got a whole bunch of information in there. We look at another one, we can see different information in there. So it's just splitting this up into chunks there. Next up, we want to make embeddings for these things. So here we're going to basically use OpenAI embeddings. So if we come in and we look at we're just setting up that this is going to be the embeddings. And then we're going to basically use this FAISS library, and we're going to just tell it from the text. We're going to pass in the text. We're going to pass in the embedding maker. So this is actually our embedding maker. And it will then create the vector store itself. And if we look at this, we can see that once we've got this created, we can actually look at the embedding function, and we can see that, okay, sure enough, it's using OpenAI. We can see the model it's using is text embedding ADA 002. We can get some other key information going on there. Now, if we want to test this out, so if I come along and say, okay, how does GPT-4 change social media? This is a query, and I pass this query in to the doc search, and I'm using similarity matching search here. So we're looking for something that's just purely the closest to this. Now, there are a bunch of different ones that you can use. This is probably the most common one that you'll see used. We'll look at some more of these things as we focus in maybe just on vector stores in the future. But here we pass in our query. By default, this is going to return 4 documents, the 4 closest documents to this, which is also being embedded with our embedding function from OpenAI up there. And then if we can see, if we look at the first result that we get back, we can see that sure enough, social media is mentioned in there. If we look here, we can see social media being mentioned in the first one that we've got back. In fact, it's mentioned multiple times in here. So we can see that semantically, it's getting good information back. And then this is what's going to be passed into our language model chain to be used for what we've got going forward with this. All right, so next up, we want to actually just build a chain. So we've done now the loading of the document. And one of the things I should point out is that even though here I've basically just loaded one document, I could load up multiple documents and feed them in the same way. And then I would just chunk them all together, which is fine. That's something that I could do in here. We can also load up documents and store different metadata with some of the vector stores as well, which is a key technique that we'll look at in the future. Okay, back to the basics for now. So we've got our plain question answering chain. So this is basically just the load QA chain. We're just using OpenAI. You could try a variety of different models here. And the chain type we're using here is stuff. What stuff means is that we're literally just going to stuff everything in to one call, right? So ideally, what we're going to stuff in there is going to be less than 4,000 tokens that we've got in there. Next up, we've got our prompt. So let me just copy this and we can just paste this in here to be able to see it easily. And we can see that, okay, this is our prompt. Use the following pieces of the context. So that's what got returned from the vector store to answer the question at the end. If you don't know the answer, just say you don't know and don't try to make up an answer. So this is where all the stuff from our database or our vector store is going to go. This is the query that we're going to put in there as well. And then it's going to answer this. So you can see here, if I come down and I ask it a query. So let's look at doing this sort of bit by bit. So I've got my query and I say, okay, who are the authors of the book? And then I pass that query into the vector store in here for a similarity search. So that would return back 4 documents. Then I pass those documents into our language model chain here, and I pass in the query as well. It comes back with an answer. Now, the answer is not perfectly correct in here. Really, the authors were Reid Hoffman, which it did get right. That's pretty good. And the second author was GPT4, looking at the book. It's by Reid Hoffman with GPT4. So it's gotten part of it right, but it's obviously it's taken the word authors that it felt like, oh, it has to be 2 people. And so that's probably why it hasn't put GPT4 there. It's looked for the closest other person that it thought would fit in there. Just to show you that what this is actually doing is using those inputs though from the vector store. Let's say I say the same query, but for the vectors, I pass in a different query. I pass in, has it rained this week? So that's getting 4 docs back up answering, has it rained this week? Then I pass those docs in and the who is the author of the book query. And you can see it comes back with the author of the book is not specified in the given context. So it means that you want your vector store to return useful information. You don't want to make the amount of documents too small. You don't just want to return the top one, because quite often the answer will be in the 3rd, the 4th, sometimes maybe even the 5th one in there. So you want to allow for that when you're doing this. So just to show you with this, you can actually set this number. So up in all these ones we've been getting 4 back, but that was just because it was the default. If we wanted to actually set it, we could set it over here. We could change it to 6 or something like that. Obviously, with the stuff method, and this is what you're going to see in a second, with the stuff method, we can only put in a very finite amount of stuff in there. So if we suddenly say, okay, K equals 20, and I return back the top 20 searches, there's going to be too many tokens and you get this kind of error. The model's maximum context length is 4097. However, you requested 5300. So you can see that's the kind of error that we would get for this. So one of the ways to get around this is to change the chain type. We've looked at these kind of chain types before in one of the videos. There are a number of different ones. Stuff is where you're putting everything in. You've got MapReduce, where you can basically do each one in parallel, and it will basically run this on each one. That can turn out to be quite a lot of, that can be quite a lot of calls though to the API. So anytime you can use stuff, it's good to use that because it's going to cost you less. The map re-rank one, let's look at this. So here I've basically asked it, who are OpenAI? And I'm asked for 10 queries back. And so you'll see that what we get back is not just a simple answer we get, because we've told it, okay, return your intermediate steps. So for each one of these things, it's gone and called the language model in there. And you can see that it returns an answer for each of them, or it returns what it got, and then it scores it as well. So if we look at the final output text, we can see OpenAI is a research organization that develops and shares artificial intelligence tools for the benefit of humanity. And then if we look at the intermediate steps, we can see each thing that we got back and then the score that it gave. So it's created an answer based on each one that it's got back. And it's obviously OpenAI is mentioned a lot in this book. And it's given some of them 80, it's given some of them 90, and it's given some of them 100. So we can see this one, OpenAI's technology company focus on, so it's gone for probably the 3 100 ones, and merged those together to give us our output there. If we come and look at the prompt for doing it this way, we'll see that the prompt is actually different. So we can see here that the prompt is basically showing it that this is the question, this is a helpful answer, this is a score, and this is for merging it all together. And it gives some examples that, okay, if something had a higher score, you'd want to pay attention to this when you're getting it back. So there's some basic chains for doing it. Another way is we can start to put, rather than have separate bits where we've got one thing to query our vector store and one thing to query the LLM, we can put it all in one chain. So here we're basically starting to use the retrieval QA chain. And what this is going to do is take a retriever. So I'm just taking the retriever that we already had, this doc search that we've set up already. And I'm just saying as retriever, passing in similarity, passing in 4 for being the number of docs that we want to get back. And then now I can basically pass this into this retriever QA from chain type. So the type I'm going to use is stuff. I'm going to pass in the retriever, and I'm going to get our source documents back here. Now you can see if I ask it, okay, what is OpenAI? What it will return back is the result, which is going to be the answer. So this is the answer similar to what we got before. And then it's going to return the source documents of where it sourced that answer from. So that we can see here. If I ask it other questions, I'll get things like that. Now, if I don't want all of that, no problem. I can just put in the query and just pass back the result. So here I'm saying, okay, what does GPT-4 mean for creativity? And I can see that, okay, the result, GPT-4 can amplify the creativity of humans by providing contextualized search. Gives us a whole nice answer for this. If we look in the book, so I've chosen sort of questions based on what was in the table of contents. Would it answer some of these questions? And I encourage you to play with this so you get a sense of what it can do, what it can't do. One of the tricks for this is that certain things that would be really obvious are not actually in the book that much. So if you think about who was the book written by, we can see that it's jumping into this, but it doesn't refer a lot to who it was written by. We've just got this one tiny bit by Reid Hoffman with GPT-4 there. So it certainly got the Reid Hoffman part, but my guess is it didn't think of GPT-4 as being a person that would write a book or as an author themselves. Another one I'll show you. So here's an example where I asked it, okay, what has the last 20 years been like for American journalism? Okay, so the last 20 years have been difficult for American journalism industry. And then it goes on to give us a full answer for that. I was curious to see. So if we come in here and we click on journalism, sure enough, for the American journalism industry, it's been 20 years of mostly bad news. And you can see that then it goes through this. So in effect, this is summarizing parts from that chapter. And what it's gone and done there is it's used the query to go to the vector store to get the information out, and then it's pulled it back and put it all together. Right? And then it's formulated an answer based on the top 4 results that it got back. Now, probably all of those results came from that chapter. Maybe not, but you could go in and have a look at the outputs and see this. So one of the big things, if you're building something for production, is you'll want to look at what your vector store is returning back so that you can be on top of working out, is your problem with the LLM if you're getting errors, or is it with the vector store not giving you the right information back? How can journalists use GPT? Gives us nice answers for these. And then another one here. Then finally, I ask it a sort of nonsense question. What is BeagleBard? Now, this is not mentioned in the book anywhere. So this is just to show you that if your model's doing well, you should get something where when it's asked a question that is out of context, it should just say, okay, I don't have a good answer for this, or this is not mentioned in any of the context given or in any of the documents in there. So this sums up just basically doing basic Q&A with a variety of different chains for doing this. So again, the key parts here is we had the document splitting, the chunking this up, creating embeddings, embedding it into the vector store. Then for the querying part, we're using LangChain to basically look up the vector store, get the relevant documents, provide that back for an LLM lookup, and that will give us the answer back. Anyway, in the next few videos, we're going to look at more fancier things that you can do with this basic setup. And all of these things are going to be generally using some kind of vector store, some kind of tool, some way of querying something and passing the context of that back into the large language model that we've got here. Anyway, as always, if you've got questions, please put them in the comments below. If you found this useful, please click and subscribe. I will talk to you in the next video. Bye for now.